Good morning, students. Let's discuss some assertion reason type of question of chapter 4. After completing the chapter, some of the students get confused in these type of questions, assertion reason. There are four options for the assertion reason type of question. One statement for assertion and one statement for the reason. And then after there is four options for writing the answer. First one is the assertion and reason are true, and reason is the correct explanation of assertion. It means the reason which is giving to you is the correct explanation of the assertion. B part is assertion, reason both are true, but reason is a not correct explanation of assertion. And in the C part, assertion is true but the reason is false. And the fourth part is assertion is false and the reason is true. These are the four options for assertion reason type of questions. So let's discuss some questions of assertion reason. So I am telling you the assertion. You can write it and just try to understand it. Assertion is if the net external force, if the net external force, you can also make the notes of this assertion reason type of question, on the body is 0, okay, then its acceleration is 0. This is the assertion. Then is acceleration. It is given to you in the question. It can be correct, it can be incorrect. Acceleration is 0. So first of all, we should understand the chapter. We should clear about every sentence, every laws. So assertion is if the net external force on the body is 0. Suppose we are not applying some force on the 0, or suppose we are applying some force on the object and the net force exerted on it. The force exerted from this side is positive, suppose, so it will be negative from this side. So here the net force acting on this will be 0. So this is the exertion, and the reason is reason for this question is acceleration does not depends on force. Acceleration does not depends on force. So this is the question. Now you should know, is it correct or not? This is the reason that acceleration does not depend on the force. We know that for if we want to change the velocity of the body, we have to apply some force on it according to Newton's second law of physical time into A. So it means that acceleration is produced only when some force is applied on the object. So it is false that the acceleration does not depend on the force, actually depend on the force. So here in this part, acceleration is true. So you will write like this is the which option? This is the C option, in which acceleration is true but the reason is false. Okay. Now the second one, acceleration is not the acceleration, this is assertion. Assertion is a rocket work on the principle of, please make the note of these assertion reason type of question with me. It will be really worthwhile for you. Rocket work on the principle of conservation of linear momentum. So first we should know what is the meaning of all the sentence. The rocket work on the principle of the conservation of linear momentum. So I think you will remember, you have learned it. Yeah, it means you have studied that. The rocket work on the principle of action reaction, or we can also say it also work on the linear momentum, conservation of linear momentum, according to which before the interaction the total momentum of the objects is equal to the total momentum of the object after the reaction, after the reaction. So it means rocket work on the principle of conservation of linear momentum. Yes, the total momentum before the action is equal to the momentum after the action. So assertion is true in this case. Now the reason is for two body system when there is a change in momentum of one body, the same change occur in the momentum of the second body, but in the opposite direction. So this is the conservation of momentum actually for two bodies system. When there is a change in momentum, there is a change in momentum of one body, the same change occur in the momentum, I think you know what is the momentum. This is the mass into the velocity. Momentum of the second body, but in the opposite direction. So what is the meaning of this sentence? It means if two bodies are acting with each other, then that momentum of one body, suppose the direction of the momentum is like this. Momentum is the mass multiplied by the velocity. The velocity has always have a direction. So according to this statement, the another body will have the same momentum but in opposite direction. It means the velocity of the body will be here like this. So in this part, second part, actually the assertion is true and the reason is true, and reason is correct explanation of assertion, and due to which we know that if the rocket, what happens in the case of rocket throw gases in downward direction towards the earth. This is called the action, and in response the earth also provide the force but in opposite direction, and this is called the reaction. So the total momentum before the reaction, when the rocket start, before it the total momentum is 0, and the momentum after the reaction, that is when the rocket is moved in upward direction, so the total momentum of the system is remain constant. So this assertion and reason both are true, and assertion and the reason is the correct explanation of assertion. Now the third one is assertion. This is assertion. Assertion is a quick collision between the two bodies is more violent than the slow collision. Assertion is a quick collision between two bodies is more violent than a slow collision. Collision means takkar, है ना? Collision even when the initial and the final velocities are identical. So first of all, we should know what is the meaning of this sentence. The quick collision between two bodies is more violent than the slow collision, even when the initial and the final velocities are identical. It means suppose two bodies are moving with some velocity. Suppose this is a truck, okay? This is a truck, a heavy loaded truck, and this is a car, a small car. So according to this statement, a quick collision between the two bodies is more violent than a slow collision, even when the initial and the final velocities are identical. So if they have the constant speed, but if they collide quickly, it means for the short interval of time, it is more violent than the slow collision. Slow collision means slow collision means they collide with each other but slowly. It means the time interval for collision is increased. According to Newton's second law, we know that F is directly proportional to the rate of change of velocity, that is change in momentum divided by the time. This is the force applied. So it means the force is depend on the time. By increasing the time, we can decrease the force. So the quick collision means the time period for the collision is very small. So in this case, the force will be large. Or in the second case, when the slow collision is there, the time is increased, so the force will decrease. So it means the first statement, this is assertion, it is true. And what is about the reason? Reason is because the rate of change of momentum, because the rate of change of momentum, sorry for that, I don't have a sketch with me today, so I'm writing with this black pen. I don't know, are you able to see it properly or not, but really excuse me for this one. Because the rate of change of momentum, you can easily, you can listen me what I am telling here. The same thing I am writing at this page. Because the rate of change of momentum which determine the force, is greater in first case. So according to the reason, it is there because the rate of change of momentum which determine the force is greater than in first case. So yeah, it is true. Because in the first case where we are applying the quick collision, so the time period will be less, so here the force will be greater. So because the rate of change of momentum which determine the force is greater in the first case, so the rate of change of momentum is greater in the first case. Okay, now the next one, fourth part. Okay, the fourth one is linear momentum is conserved in both elastic. Total energy is conserved in all collisions. So according to it, it means the energy remain conserved for every collision. Here it's also true that according to the conservation of energy. But now in the assertion part, we are explaining about the momentum, conservation of momentum. So both are true, but reason is correct and is not the correct explanation of assertion. This is the B part, in which both are true, but reason is correct, not the correct explanation of the first part. Few more questions of assertion reason. This is the question number 5. Assertion, I am writing it like A. Assertion, force required to accelerate, force required to accelerate a mass in two perpendicular direction is never same. Force required to accelerate a mass in two perpendicular direction is never same. Is never same. Force required to accelerate a mass into perpendicular direction is never same. Okay, and the reason is so according to this one, the force required to accelerate a mass into perpendicular direction in this direction or in this direction, the force will be different, because in this direction the force will be applied according to the how much the gravitational force is acting on it, and in this direction it depends on the friction. So the force required to accelerate a mass into perpendicular direction is never same. Yeah, it's true. Now the reason, the presence of G will not influence the presence of G is the acceleration to gravity. The presence of G will not influence the acceleration. Yeah, it is totally wrong, because we know that the presence of G will not influence the acceleration. Yeah, it will influence the acceleration. Actually, the force required to move the body in upward directions totally depends on the acceleration due to gravity. It's on G. So it means the presence of G will not influence the A. It's totally incorrect. So here assertion is true but the reason is false. This is the C case in which assertion is true but the reason is false. Now the next one, Exertion. Assertion is while walking in ice. While walking, when you walk on the ice, you know it's not easy to walk on ice. One should take a small step to avoid slipping. You slipped when you step on the ice. One should take small steps to avoid slipping. So this is the assertion. Now the reason is, you should know if you want to steps on the ice, you want to walk on the ice, the step should be small. That's why you will not slip on this one. Reason is, this is because the smallest step ensures small friction. Yeah, these both are true, and this is also the correct explanation of assertion. Reason, this is because smaller steps ensure smaller friction. So you know, you walk on the floor also due to the friction, or if there is no friction, you are not able to walk easily. Next one. These are the assertion reason type of question. So you should know that your concept should be very clear so that you can answer any question. Acceleration. A body is momentarily at rest when it reverses the direction. A body is momentarily at rest when it reverses the direction. Clear? So body is momentarily at rest when it reverses the direction. Suppose a body want to change the direction, momentarily it will on rest. Like when you throw a ball in upward direction, what happens? Actually, after reaching the highest height, it momentarily rests and then comes down. So the reason that is, so it is true, the assertion is true. A body cannot have acceleration if its velocity is 0 at the given instant of time. So to say that the body cannot have acceleration if its velocity is 0 at given instant of time. It means if its velocity is 0, it would not have any acceleration. This is totally false. So here in this case, assertion is true, but the reason is false. These are few questions of assertion reason type. Okay.